last topic for this section. Okay, last topic for this section is whenever you have the quotients between your radicals. Okay, if you look at the box, it kind of tells you a little bit about it. Okay, especially in the examples. Now, you've done problems like this in the past. Okay, like this one here. You guys have done that right there. Okay, freshman year, hopefully. Okay, I hope so. Anybody know what type of problem would you do? What's it called for getting rid of the 3 over rad 5 right here? Starts at rationalize. Okay, now we're going to go take this one into detail. Now, freshman year, you would just say, all right, times by. You would do top and bottom by the square root of 5. Okay, and then you would rewrite that as 3 times rad 5 over 5, right? And you would call it good. Why 5? Why 5 down below here? Okay?
No.
Chamberlain?
Oh, I got you. Because you gotta find your these
Not necessarily. Rainy?
Oh, because anything times itself can make a perfect square?
Okay, yeah. All right, that's why you choose 5, right? It's what's in the denominator as a radical. So when you had that rad 5 times that rad 5, it's going to give you what? Square root of 25, which ends up being 5. And that's the whole goal of the problem. You need to get rid of you need to get rid of that rad in the denominator. That's the whole point. That's the only thing that's wrong with 3 over rad 5. Okay, so your step to rationalize it is multiply by square root of 5. Do it on top and bottom, because remember this line here has to look like 1, right? Rad 5 over rad 5 is 1. Make it 3 rad 5 at the top, rad 25 on the bottom. Take the square root of 25, you get 5. And you're done. Okay, Jack?
What's that thing where it's like, you like square, like it's a problem like that, you like square it and then like you take the radical off and then you go from there? You know what I'm talking about? No. Okay.
No, I can't. No, I don't. I'm thinking maybe something with equations, maybe.
I don't know.
Okay. Because this you won't square anything here. Okay. All right. Everybody good? Now that's a freshman year problem. Mm-hmm. Yeah, for real. My freshmen are going to do that here in a couple months.
Couple months.
Yeah, we got 3 months of the year. A couple is 2. We'll do it in April. I mean, give me a break. You guys make it sound like I'm behind with the freshmen. I'm actually ahead. I don't know what I'm going to do with them in May. Okay. Here's where we are.
God.
Oh, no.
Go ahead and say.
Oh, boy.
Oh, do you still use that 2?
Okay.
Or are you still using 2 like the index?
Still index of 2. Always the first thing you do, look at your index. Okay, because that index, like I said, most powerful number in the chapter. It tells you what to do. Okay? We want to take the square root of these. Now, if you see this written as one big square root, like it is here, your first step is to rewrite it as 2 little square roots. Square root of x to the 6th over the square root of y to the 7th.
Do you,
Okay. Yeah. All right. Now, this won't be able to be done every single time, but in this case, you can. If you can simplify those square roots, do so. Okay. So what's the square root of x to the 6th? X to the 3rd. What's the square root of y to the 7th? Y rad y. Okay, you have, or y cubed rad y. Sorry. There we go. Okay, you have 3 y's inside. You have 1 left over. Everybody good? Okay. If you're saying skip this line, that's fine. That's 100% fine. Okay. Now I'm going to move this guy down here so I can have a little more room. Okay. Dosary magic. Ready? Oop, there it went. Okay. All right. Now, what's still the problem with this problem?
Still got a rad in the denominator.
Still got a rad, okay? So just like how last time we multiplied by rad of 5, this time we're going to multiply by
Rad of y.
rad of y.
Rad of y.
Okay? Which will give you x cubed
Rad of y.
rad y
And
all over. Now, y cubed square root of y to the,
Why get?
Isn't it one?
hold on, inside, so we got y cubed, because you multiply the insides of your y, so square root of y to the second, right? This y times this y, inside your radicals. Okay? The square root of y squared is y. Y times y cubed gives you y to the fourth. So you have x cubed square root of y over y to the fourth. You're simplifying, not solving, so there are solutions. Okay, so you have the fourth root of a big fraction of 6 over 5x. First step, split it into two little fractions, okay? Make sure when you split, though, make sure that index goes to each one. Okay, it doesn't become like a fourth root over a square root or something stupid like that. Okay, that fourth root goes to each. Okay? All right, now, let's do some deeper thinking about the problem we just finished up on. Y times the square root of y. Well, the answer used to be is this. The answer used to be, Mr. Mormon, that's because that's what's in the denominator, and you just multiply by what's down there. So it used to be the answer when you were a freshman, and I accepted that, and I'm like, oh, good for you. Why now? Why did we multiply by the square root of y by another square root of y? What does that accomplish for us? Lit.
Gets rid of the rad.
Because y times y is what?
Y. Squared.
Y squared, and the square root of y squared is y.
Y.
Okay? That's why whenever it was freshman year, and you just multiply by what's there. Okay? Because this times this gives you the square of it. You take the square root of the square of it, you're left without it. Make sense? Okay. Now, what root is this one? The fourth root. Okay? So we have to make these be fourth powers. Okay? We can't just do squared powers now. We got to make these be fourth powers. Okay? So, to make this make sense, we're going to ignore the 5 for now. We're going to work with the x. Okay? So if we want the fourth root of 5x to be gone, we need them to have fourth powers. We know every single time we're going to multiply by a fourth root of something. You can't change your indexes. Okay, you can't do a fourth root times a square root. That's not a thing. So we know we need fourth roots. Okay? We need x right here to have a power of what? 4. Right? Because we need to get rid of it underneath a fourth root. So we need to multiply x by something that's going to make it have a power of 4, which would be x to the third. Good. Okay? 3 different answers, but yeah, pretty much. All right? X to the third. All right? X to the third. Okay?
So
Everybody
you
good?
can just add numbers and take them out as you please.
No. I mean, you could as long as you do top
I've
and
always
bottom.
wondered that.
But
like,
what's the point? But there's purposes to this.
You're like math musicians. So you make this.
Like here's the thing. Okay, hold on.
That's what I said.
I don't want to. Okay. Now I did it with the x first to show you that. Okay, you want to be x cubed. Reason I did this. Okay. Now let's think about this with 5. We have 5 underneath the fourth root in the black in our original. Okay. We need to make it be a fourth power. We have 1 5. How many more do we need? We need 3 more, right? Okay. Now, some of you probably instantly go, okay, 5 cubed, 125, done. Okay, don't. You need 3 more 5s. 5 cubed. Okay, you need that there. You need that there. Okay, you'll see why. There's a method to the crazy man's madness. I promise. Okay? All right. Now, the black, obviously the black comes from just splitting the two radicals up, yes? Everybody see that? Okay? The blue comes from your head. Okay? Yeah, it comes from your noggin, from that mush stuff. Your skull protects. Okay? Now, your next step after you have that set up is you put these together. Okay? So we're going to let our denominator dictate what we do. Okay? And I'm going to do it a little odd just to make a point. So we're multiplying these fourth roots together. We'll have a fourth root. We already said x times x cubed gives us x to the fourth. All right, what's 5 times 5 cubed? 5 to the fourth.
Oh,
Also known as
6.
625.
Oh.
Okay? It is 625, but
You want to say
write it as 5 to the fourth. Because you're going to take the fourth root of it.
But that's just the 5. There's no.
Oh, not there yet. We didn't take the fourth root of it yet.
What?
But either way, it's fine.
But it's the 5.
Okay. Now, your denominator is going to be 5x. Your numerator, though, if you do the 5 to the fourth, that's fine. Okay. Your numerator is different. Your numerator just is what it is, man. Okay. So you actually have to do the 5 cubed times the 6. All right. When you do those inside, which gives you 750, I believe. Yes. All right. So you have the fourth root of 750 x to the third. Okay. All right. Hang tight. What's the fourth root of 5 to the fourth? 5. Fourth root of 5 x to the fourth? X. Now, does 750 break up? Not in the fourth root. Okay, because look what made it. There we go. 3 5s, a 6, which goes 2 3. So your factor tree of it is 2 3 5 5 5. How many do you need in a group? 4. So does 750 break up? No. In most cases, it won't.
But so you don't combine like turns like you at the top, the bottom.
We're gonna do it right here. Here we go. Everybody ready?
Wait, is it 8 red?
Shh, quiet. We're crossing out 13. I'm going to take 14 and split it up and move it down here. So the fifth root of 3 over the fifth root of 4y. Okay. We're going to put up some blue ink. All right. We need these to be powers of 5. So we're going to multiply that by the fifth root of 4 to the fourth and y to the fourth. Because you need 5 4s, right?
Yep. I bet I'm the only person that got it right.
Okay? So you have 1 4 here. You have 4 more here. 4 times 4 times 4 times 4 times 4. 4 to the fifth. You don't care what that actual number is, but it's 4 to the fifth. Because you're adding your bases like chapter 5, right? Okay? Now, what we're going to do next, we're going to take it. We're going to make this the fifth root. I'm going to check you guys' answer just to make sure we're good.
I got 250.
All right, good job on the 768. Y to the fourth over the fifth root of 4 to the fifth, y to the fifth, which equals the fifth root of 768.
Wow. Can't you break that down?
Hang on. Let me write. I love you guys are thinking, but let me write. Over 4y. That you check and see if your problems can what? If your radicals can reduce. Okay? So, what I'm going to do up here in the top right corner is take that 768. All right? And I'm going to start cutting it down by
8.
Okay, sure, whatever.
No, 16.
Or I'm going to do, actually, you know what I'm going to do? I'm going to go bigger.
7
I see
38.
5.
I'm going to go 32 and 24.
Wow.
Dylan's eyes got big. What? How did I see that? I'm good. That's how I saw that. Okay.
You could also do 64 and 12.
You could, but I don't care about them. Okay? The one I care about is 32 and 24. Okay? Now, I need how many in a group? 5. Okay, so I'm going to go 32. 32 goes 4 and 8. 4 goes 2 and 2. 8 goes by 2s, 2, 2, and 2. There's my 5. Right there. Everybody see that? Okay. My 3-leaf factor tree on 8. 24 goes what? 2 and 12, 2 and 6, 2 and 3. So you get 3 2s and a 3. So we got to put all that back together. Because you got 5, fifth root.
Yeah.
Okay, everybody see that? Okay, so your numerator then simplifies to the fifth root, or sorry, hold on, 2 times the fifth root of 24y to the fourth, all over 4y. And then you can do what with that 2 and 4?
Reduce.
Reduce it. So the fifth root of 24y to the fourth, all over 2y. That's your final answer, ladies and gentlemen. Because that 2 and that 4 cancel.
So what you do?
I'm going to show you a shortcut. Ready? I'm going to show you a shortcut. And this is the reason why I want you to know those numbers. Okay? Now you can write this or you can pay attention and then like go, oh my gosh, it's so much easier later. I'm still taking the fifth root of 3 over the fifth root
Is this 14?
of 4y. Still 14. Okay? My question is this. 4. Okay? 4. Whoops. Whoa, where'd you go? 4. You can rewrite as what? To the 2 squared. So instead of thinking about this problem as you need 4 4s, you really need how many 2s? 3. Okay. Your variables stay the same, they don't change. Okay. Doesn't it? See what's about. Watch what's about to happen. 2 cubed is 8. Up top now. 2 cubed is 8. 8 times 3 gives you 24. So the fifth root of 24 y to the fourth all over your denominator. 2 times 2 times 2 times 2 times 2 is 2 to the fifth. Fifth root of 2 to the fifth is 2. Y times 4y gives you y to the fifth. Square root of fifth root of y to the fifth. Two over rad 5 minus 1. You multiply this by a conjugate. Okay? Conjugate of rad 5 minus 1 is rad 5 plus 1. Rad 5 plus 1 up top. Okay? Distribute up top, so 2 rad 5 plus 2 all over. Rad 5 times rad 5 gives you 25. Remember, your middle 2 should cancel since they're conjugates. Negative 1 times positive 1 gives you minus 1, which leaves you flipping that 2 plus 2 rad 5 over 24, and still reduces because you have 2's going to all 3 parts. Everybody see that? So it's 1 plus rad 5 all over 12. That's your answer.